Good morning, students. We'll start with the today's lecture, and this is the unit 5 and last chapter what we are going to cover here. Okay, 1 minute. My pen is not going to be detected here. What happened? Yes, fine. This is the unit 5 last chapter, that is introduction to state variable analysis. Okay, in this what all the things we are going to study, just I will brief you out. Concept of state variable and state models for electrical systems, solution of state equations, transfer function from the state model. Okay, if I read out like this, you will not understand anything, right? Okay, we'll cover in detail, right? Okay, what are the topics that we are going to cover today? Brief introduction to this state variable analysis or technique we'll see. Then what is concept of state, and few definitions are there. We'll try to understand those definitions. Then the next state differential equations and the state model of linear systems also we'll see one by one. Then state model of single input, single output system. Then state diagram representation. Then state diagram of standard state model. Then state variable representation using physical variables, and we'll see the few numericals, that is how to obtain the state model of the given electrical system. Okay, these are the topics that we are going to cover. I hope you have not understood anything. We will try to understand all these things, right? Okay. Introduction. Yes, there are two approaches in order to analyze the given system, right? One is conventional approach and another one is modern approach. What is conventional approach? How to study the behavior of the linear time invariant systems that we have seen using the time domain methods as well as the frequency domain methods. In time domain methods, we have used the root criteria, right? Root criteria and also the root locus technique, that was time domain methods. They are all conventional approaches. Then next, in frequency domain methods, the Nyquist plot and the Bode plot, right? We have seen Nyquist plot and the Bode plot, and also the polar plot, right? Polar plot is the basis for the Nyquist plot. So these are all conventional approaches in order to analyze the given control system. Okay, the systems are modeled using transfer function approach in all these things, right? We have studied. And what are the limitations of this conventional approach, whether root criteria, root locus technique, or Nyquist plot, Bode plot, right? We'll see the limitations. Okay, initial conditions are neglected. Yes, initial conditions we have not taken into account. Then the methods are insufficient for higher order system. For first order and second order system, they are fine. But if we go for higher order system, third, fourth, fifth, and so on, these methods prove to be insufficient. And they are not suitable for multiple input, multiple output systems, MIMO. They are suitable only for single input, single output systems. They are suitable, but the complexity involved will be more, right? So they are not suitable for MIMO systems, multiple input, multiple output systems. Then analysis of systems for specific type of inputs, right? Okay, we have analyzed the system only for specific type of input, such as unit step input, unit ramp input, if you remember, right? Not for any kind of all kind of inputs, right? So, and it is applicable only for linear time invariant systems, right? What about non-linear systems? They are not applicable, right? And they fail to give the optimal solution. Optimal solution is feasible solution, which is beneficial and economical, right? These are the limitations of those conventional approaches in time domain method as well as frequency domain method. Then we'll think of the other method, that is modern approach. What is that modern approach? Is the state variable analysis, also called as state space analysis. This is the modern approach to study the behavior of the systems. What this kind of technique this uses is, it makes use of the internal state of the system, considering all the initial conditions. The initial conditions are considered, and also all the internal states of the system are considered. This we'll see one by one. You will not understand if I say what is internal state and all those things, right? So we'll slowly build up and we'll try to understand each and everything. So one thing you remember that, yes, it makes use of the internal state of the system, considering all the initial conditions. So this is the state variable analysis method or state space analysis method or technique, right? Okay, what are the advantages of the state variable analysis? The limitations are here of the conventional approach are the advantages here. So the effect of initial conditions are taken into account. Yes, initial conditions are considered, and it is applicable for both. You can see here non-linear as well as linear time varying systems, and it is applicable for multiple input, multiple output systems. Optimal solutions are obtained. Any type of input can be considered, right? Any type. The input may be of any kind. Then the method involves the matrix algebra, right? So since the method involves the matrix algebra, digital computers can be adopted for computations, right? Then state variables need not be physical quantities of the system. What are state variables? We have to understand, we'll study, right? But right now state variables need not be physical quantities of the system. We'll see one by one, right? After studying this today, everything, once again you come back to limitations, advantages and read, you will understand whatever the thing I have told, right? Once again you have to come and read after covering this entire chapter, today's lecture, right? Then mathematical representation of system using vector matrix notation, right? We will try to represent the system using the vector matrix notation. The disadvantage of this state variable technique is it is time consuming because of several computations are involved, right? Because of several matrix calculations, right? All those several computations are involved, hence it is time consuming. That is the only disadvantage. Okay, first we'll try to understand the concept of state. What is state? Before understanding the state, so in order to understand the concept of state, let us take some examples. Okay, how to understand the first we'll take the example of football match. You can take any match, cricket match also you can take, not only football match. Okay, if I take the football match, the score updation process depends on the past score. For example, if I want to say whether team A has won or team B has won, I have to wait till the all the scores are updated. If okay, suppose the match is of 1 hour, right? For 30 minutes I cannot judge. The score should get updated, right? Till the final score is reached, all the past scores should be considered in order to judge whether the which team has won, right? All those past scores are nothing but the state of that particular match, right? The so score updation process is the one of the example in order to understand the concept of state, right? I hope you understood score updation process, right? You can take cricket match also, which team has won. In order to judge that, I require all the previous scores, right? Based on the previous scores and the present score, we will decide whether the which team has won, right? Final score should be updated by considering all the past scores. Then we'll take example of electrical network in order to understand the state. Okay, we'll take the example of electrical network. Here you can see the voltage source V in, the resistor R, capacitor, and the voltage V out is measured here, right? Okay, in order to find out the output voltage V out, then what is required? The knowledge of initial capacitor voltage must be known. What is the voltage across capacitor? That should be known, initial voltage, right? That's the initial condition in order to find out V out. Okay, and we call this system as dynamic system. We call this example of electrical network as dynamic system. Why we call it as dynamic system? In the systems having memory. Okay, we just have to define it. You can observe here the systems in which the output is not only dependent on the input but also on the initial conditions are called systems with memory or dynamic systems. The dynamic systems are those in which the output depends on the input as well as the initial conditions. What is the initial voltage across this capacitor? Also the input, right? I hope so. Such systems are called as dynamic systems. The systems in which the output depends on the input as well as the initial conditions of the system. We call such systems as dynamic systems or systems with memory. If any doubts are there in between, please unmute yourself and talk to me so that I can clarify the doubts immediately, right? Don't keep the doubts with you. I hope you have understood the dynamic systems. Dynamic systems are those which are having memory, right? And the output depends on the input as well as the initial conditions of the system. Here the V out depends on the input as well as the initial capacitor voltage, right? Then okay, we will replace this capacitor by one more resistor R1. Let me take R1, right? Then this becomes this was the example for dynamic system. Now if I replace this capacitor by another resistor R1, this becomes static system. What is static system? We'll study static system. You can observe here the output V out depends only on the input here. It does not depend on the voltage across these resistors. It depends only on, you can observe here one more thing. The energy storage elements, they are going to affect. Energy storage elements in electrical network is inductor and capacitor. The current through the inductor and voltage across the capacitor, they are the state variables, we call it as, right? So the resistor does not contribute anything to the system state of the, it will not affect the state of the system. The resistors do not affect the state of the system, right? So the output depends only on the input. So hence we call it this type of systems as static systems, right? V out depends only on the input here, not on the initial conditions of the system, right? So such type of systems we call it as static systems. the systems in which the output of the systems depends only on the input applied at time t equal to 0, right? Initial time t equal are called the static systems, or systems with zero memory or no memory. I hope you understood by taking the example of previous electrical circuit and this one, right? The output depends only on the input at time t equal to 0, and it does not depend on the initial conditions of the system, right? Such systems we call it as static systems. Okay, we will define what is state, right? Just I've underlined here what is state we will define, and what is complete state of the system, and what is state vector. We will try to understand one by one, right? Okay. The state, just I will read out, just try to understand. The state can be regarded as compact and concise representation of the past history of the system. For example, in football match, what are the state? The previous scores, right? We have to keep on updating the score. If I don't update my score, then I cannot get the final state of the system, right? I should keep on updating the past scores in the football match. Then only I will get the what is the current state of the system, right? So we will define the state of the system as compact and concise representation of the past history of the system. Past history of the in football match, past scores are the past history, right? So compact and concise representation, right, of the past history of the system. This we call it as state. There is another definition of state, we'll see refined next, we'll see. Right now we have defined what is state. Then next, what is complete state of the system? You can just, I'll read out here. The complete state of the system can be considered to be a vector having components which are variables of the system which are closely associated with initial conditions. So state can be defined as a vector x of t called state vector. I hope you have not understood anything. Okay, for let take that electrical network consisting of a resistor, inductor and capacitor. We will consider the simple electrical network consisting of resistor, inductor and capacitor. So inductor and capacitors are the energy storage elements, right? These energy storage elements are nothing but which are going to vary. The current across the inductor, that is the current flowing through this inductor also will vary, and the voltage across the capacitor will also vary, right? So these are the variables, state variables. Okay, this current, this is one variable, this is also going to vary. The capacitor, this is another variable, this is also going to vary, right? Considering all the state variables, right, we have to consider not only one variable, the variation in the current, the voltage across the capacitor, variation of voltage across the capacitor should also be taken into account, right? So the complete state of the system, now I hope now you can understand. The complete state of the system can be considered to be a vector having components. Which are the components? Inductor and capacitor, which are nothing but the variables of the system, right? For inductor, current is the variable, current through the inductor. For capacitor, voltage is the variable, which are the variables of system which are closely associated with the initial conditions. So right, we will consider all these state variables. So state can be defined as a vector x of t called the state vector. I hope you understood, right? We have to consider all the state variables contributed by the system components. For example, in this example, inductor and capacitor are the system components, and the variables are current through the conductor and voltage across the capacitor, right? Okay, only two state variables. And if I list out all those state variables in the form of a vector, then such a vector I will call it as state vector, right? X of t is equal to x1 of t, x2 of t and so on till xn of t, n number of state variables, right? And this is the matrix of the order n cross 1, right? N number of rows and only one column. And this vector we call it as state vector. Then how to define state vector? It's the vector consisting of all the state variables. Simply I can write it's a vector consisting of all the state variables. For example, if I take this example of electrical network consisting of RLC, right? So here there are only two variables, that is current through the inductor and voltage. So only two variables, x1 and x2. There is no third and fourth variable, right? If I consider this particular example, if I consider generally there are n number of variables listed in the column vector form, this we call it as state vector, right? I hope you understood what is state vector, what is state, what is complete state of the system, what is state vector, right? State, it gives past history of the system. Complete state, it gives all the state variables, what are the effect of all the state variables, right? All that is the information, and the representation of all the state variables in the form of a vector we call it as state vector. So state vector once again, and this x1 of t, x2 of t, x3 of t, and so on xn of t, we call it as state variables of the system. State variables of the system. In that example, in the inductor and capacitor, the current through the inductor is a variable and the voltage across the capacitor are the variable. These are the variables, and these are the physical quantities. Physical quantities. I hope you understood. The variables associated with physical quantities, the physical quantity inductor is current and the physical quantity capacitor is voltage. These are the variables. So the state variables in this example is current and voltage. Current and voltage. I hope you understood, right? Okay. And this we call it as state variables of the system, x1, x2, and so on till xn. Then what is updating of the state? Okay, updating the score in the football match, I told, no, right? Okay, team A has scored 4 at time t equal to t naught, and at time t equal to t1 the score may be same or it may be update. Maybe they have scored one more or two more points, right? Maybe 5 6 like that. Okay, so updating of the state is very important. Okay, initially I have some score at time t equal to t naught. Let me call it as x of t naught. At time t equal to t naught, the state of the system is x of t naught. So in order to get at time, okay, at time t equal to t naught, the state of the system is x of t naught. So at time t equal to t1, right, at time t equal to t1, the state is x of t1. How it is obtained? Between time t0 and t1 there are variations in the system. The state has to be updated between time t0 to t1, right? Means the xt of 1 is the state that is obtained by considering the previous state, past history of the system, right? Previous state should be given importance, right? Between time t0 to t, right, what all the inputs we are applying, what are the variations that are in the system, right? X of t1 depends on x of t0. I hope you are getting, right? So x of t2 depends on x of t0 as well as x of t1 at time t equal to t2 and so on. So updating of the system is very important because then only I will get the correct state of the system. Then what is order of the system? Okay, we'll study the number of state variables of a system. It will give me the order of the system. The number of state variables. For example, if I consider simple RLC, then only two state variables are there in the current and voltage. So its order is 2 because only two state variables are there. These are the state variables. So number of state variables n equal to 2. Hence it is equal to order of the system in this example, right? Okay, I hope you are getting. The number of state variables gives me the order of the system. The number of state variables for a system is equal to the order of the system. The number of independent variables, okay, the x1 x2 and so on xn till they may be dependent variables or independent variables. For example, we will consider the simple electrical network, the capacitor voltage and the current in the inductor. These are independent variables, right? These are independent variables. Means the number of energy storage elements in the system are nothing but they are representation of the independent variables. Energy storage, for example, in electrical system the energy storage elements are inductor and capacitor. The variables associated with inductor is current, the variable associated with capacitor is voltage. So current I and voltage V across the capacitor are independent variables. This is in electrical system. In mechanical system, which are the energy storage elements? That is damper element and spring element. Damper element and spring element. For the damper element, which is the variable? That is velocity. For spring element, displacement. Displacement. I can write it as yes, displacement. For spring element, the variable is displacement. For damper element, the variable is velocity. Yes. Any doubt? Somebody has unmuted. Okay. For damper element, velocity. For spring element, displacement. So velocity and displacement are the independent variables. This is one example I have given, right? I hope you understood. So the number of independent variables is equal to the number of energy storage elements present in the system and the variables associated with the energy storage elements, right? This is for electrical system and this is for mechanical system. But we'll concentrate our study only for electrical systems, not for mechanical systems. Okay, we will define all these important definitions, right? What is state? What is state variable? What is state vector? what is state space, what is state trajectory. Already we have defined state, state variable, state vector. We will refine our statements here, right? Okay, you can see here the state, how the state is defined. The state of a dynamic system. What is dynamic system? The system having memory. Because the system having memory, we call it as dynamic system. It depends on the input as well as initial conditions of the system. Please keep in the mind, right? The state of a dynamic system is defined as the minimal set of variables such that the knowledge of these variables at time t equal to t naught, at time t equal to t naught means initial condition of the system, together with the knowledge of the inputs for t greater than or equal to t naught, completely determines the behavior of the system. Yes, we have already defined, because it depends on initial conditions of the system and the inputs of the system for time t greater than or equal to t naught. That will give me the state of the dynamic system. It depends on two things. One is the initial condition of the system at at time t equal to t naught, what are the variables, and for time t greater than or equal to t naught, what are the inputs, right? The knowledge of the inputs. These both will contribute to the uh, definition of state or the behavior of the system, that we call it as state, right? Then next, state variables. The variables involved in determining the state of a dynamic system. The variables involved in determining the state of a system, we call it as state variables. Here already I told in the previous, let me take 1 minute. Yes, this is the state vector, right? x1, x2, xn. Till xn, these are the state variables, x1, x2 and xn, right? And this x of t is the state, and the vector is state vector. Okay. The variables involved in determining the state of a system, dynamic system, are called as state variables. That is x1 of t, x2 of t, xn of t are nothing but the state variables. And here these state variables are normally the energy storage elements contained in the system. For example, in electrical network, inductor and capacitor are the energy storage elements. In mechanical system, the damper element and the spring element are the energy storage elements. Next, state vector. The state vector, it is the vector sum of all the state variables. It is the vector sum of all the state variables. We call it as state vector. Suppose I can write it like this. Suppose x of t is equal to x1 of t, and I have only two state variables. Then I can write it as vector sum x of t vector is equal to x1 of t vector plus x2 of t vector. Vector sum of all the state variables will give me the state vector, right? I hope you understood. If there are n, just go on adding till. So the vector sum of all the state variables will contribute to the state vector x of t. And you can orthodox definition is there, you can go through it. The n state variables necessary to describe the complete behavior of the system, it can be considered as n components of a vector x of t, called the state vector at time t. That is one way, or else you simply say the state vector x of t is nothing but the vector sum of all the state variables. This is simple, I think, right? Okay. Then what is state space and state trajectory? This you will not understand anything now. If I go to the next slide and explain few things, then you will come to understand what is state space and what is state trajectory. Okay, I will just read out, just try to understand, or else I will explain these concepts in the next coming slides. The space whose coordinate axes are nothing but the n state variables with time as implicit variable is called state space. Suppose there are n state variables, means n coordinate axes will be there. If there are only two state variables, there are two axes, x1 axis and x2 axis, corresponding to the state variables, right? Time is implicit variable with respect to time. What are the variation in, what are the change in the state, right? If there are n number of state variables, then there are n number of coordinate axes, which is very complex, right? And this we call it as state space. The space whose coordinate axes are nothing but the n state variables with time as implicit variable is called state space. I will tell you next in the next slide. Then what is state trajectory? It is the locus of the tips of the state vectors with time as implicit variable. Yes, time is the implicit variable for both state space as well as state trajectory, but it is the locus of the tips of the state vectors. Okay, we'll try to understand the state space and state trajectory by considering the second order system. Okay, definitions can be explained by considering the second order system. Let us consider the order of the system is 2. So the number of state variables is 2. That is x1 of t and x2 of t, and this is the state vector. state vector we will write for the second order system. X of t is equal to x1 of t into x2 of t. We have considered order is 2. So we have taken this is one state variable x1 of t and this is the second state variable x2 of t. And what is state vector? The vector sum of all the state variables. So x1 of t vector plus x2 of t vector, that is x of t. This is the vector addition. This will give me the state vector, right? The vector sum of all the state variables is nothing but the state vector. I hope you are getting. Then what is state space we have to understand. Since this is second order system, the state space is a plane here, right? It is a plane. You can observe here. For second order system, there are only two state variables, x1 of t and x2 of t. So you can observe here, this is x1 of t axis and this is x2 of t axis. You can take anywhere. You can take x1 here, x2 here, no problem. So this is x1 of t axis and this is x2 of t axis. Only two axes are there because it is a second order system. You imagine the complexity. If it is n order system, how many coordinate axes will be there? N coordinate axes, right? So I cannot imagine, right? So for second order system, right now I can understand. This is x1 axis and this is x2 axis and this is the origin 0, 0. But time is the implicit variable already. With respect to time only I have to define, right? Time is the implicit variable. Okay, observe. At time t equal to t1. So this is x1 axis, x1 of t and this is x2 of t for second order system. So this is at time t equal to t naught. At time t equal to t1, this will progress somewhere. At time t equal to this will also progress somewhere, right? The state variables are going to change. So here they have changed. This is at time t equal to t1. So let me call it as x1 of t1 and let me call this as x2 of t1. And here we are getting this is nothing but x of t1. This is the state, right? At time t equal to t1, the state is xt. The state vector is xt1 vector is equal to x1 of t1 plus x2 of t2. Sorry, x2 of t1. I hope you understood this, right? Next, we will consider another time. At time t equal to t2. At time t equal to t2. Okay, this is x1 of t, x2 of t. At time t equal to t2, this is x1 of t2 and this is x2 of t2. So corresponding point will come here, join it. This will give me x of t2, right? So at time t equal to t2, the state is x of t2 is equal to x1 of t2 plus x2 of t2. Okay, for time t equal to t1, I got this x of t1 vector here. At time t equal to t2, I got x of t2 vector here, right? So let me represent both the states at time t equal to t1 and t2. At time t equal to t1, this is x of t1. At time t equal to t2, this is x of t2. So I got 2 points here. Similarly, if there are n numbers, you can imagine there are n number of points we are going to get root locus tips. So the locus of the root locus tips is nothing but the state trajectory. I hope you understood now what is state space and state, right? What is state space and what is state trajectory? The space whose coordinate axes are nothing but the n state variables. If it is second order system, there are only two state variables and two coordinate axes. If it is having n number of state variables, if n number is huge, there are n number of coordinate axes. Can you imagine? Right? It is too difficult to imagine, right? So for second order system only we have seen, right? So, but time is the implicit variable in both the cases, state space or state trajectory. State trajectory is nothing but the locus of the tips of state vectors. Locus of the tips of state vectors with time as implicit variable. So these are the locus of the tips of the state variables, right? X of t1 and x. So join it from here to here. This we call it as state trajectory. I hope you understood. Any doubts you can ask. I hope you have defined state, state variables, state vector, state space, state trajectory. No need to remember. If you understand what actually it is, that is sufficient. No need to mug up these definitions, right? What actually it is, that is sufficient. These terminologies we should be knowing it, that's all. Okay, next we'll move to the next topic, the state differential equations and state model of linear systems. Sometimes we call the state differential equations as simply state equations. We will eliminate this differential equations, right? Simply we call it as state equations and state model of linear systems. These state equations are written in the form of differential equations, hence we call it as state differential equations. We'll see. Let us consider the system here, MIMO system, multiple input, multiple output systems. There are multiple inputs. You can observe here u1, u2 and so on till um. They are all functions of time, u1 of t, u2 of t, um of t and so on, right? These are the inputs and these are the outputs of the system. So how many inputs are there? M number of inputs, are there, and p number of outputs are there, p number of outputs, y1, y2 and so on till y of p. And the internal states of the system, I told no, internal states. The system is having some internal states. Let me call it as x1 of t, x2 of t, x3 of t and so on, xn of t. So there are n number of state variables. This is n number of state variables. These are the internal states of the system. You observe, these things should be clear. M number of inputs, n number of state variables or n number of states, and p number of outputs. M, you take the letter M, N, P. Observe here, M, N, P. Why I am stressing, you will come to know. M, N, P. O is not there, M, N, O, P. Right? M, N, P. M refers to inputs, N refers to the number of states or state variables, and P refers to the number of outputs. Please try to understand. M, N, P. I am stressing a lot once again, right? M stands for inputs, N for the number of state variables, P for the number of outputs. M and P. Right? We can write the inputs, the state variables and outputs in the form of a vector. That is u of t is the input vector, u of t is the input vector, that is u1 of t, u2 of t and so on till um of t. M number of inputs are there, right? I hope m cross 1, m rows 1, only one column. And if I take the state vector, that is x1 of t, x2 of t and till xn of t, n cross 1 is the order, right? N number of rows and only one column. And if I consider the output vector, so y1 of t, y2 of t and yp of t, p cross 1. So this we call it as input vector, and this is the state vector, and this is the output vector, right? So all are, I have written the orders, so m cross 1, n cross 1 and p cross 1 respectively. I have written the orders, right? Please try to have the diagram, this memo system in your mind. M, N, P. M refers to the m number of inputs, N refers to the number of state variables, P refers to the p number of outputs. Okay, then what are these state differential equations and state model? We'll see, right? First we'll see state differential equations, right? The state variable representation of the given system. For example, see here, I have n number of state, x1 of t, x2 of t, x3 of t and xn of t, right? Let me take this, let me represent this state in the form of differential equations. Means x1 of t, x2 of t, x3 of t, x3 dot, x1 dot means dx1 by dt, dx2 by dt, dx3 by dt, dxn by dt. We will represent these state equations in the form of differential. So let us take differentiation with respect to time, right? So dx1 by dt, dx2 by dt, dxn by dt and so on. How to write it? So dx1 by dt can be written as x1 dot. This dot indicates dx1 by dt. It is single differentiation. If there are two dots, it is two times differentiation, right? So we know this notation. x1 dot of t means we are differentiating x1 with respect to time t. x2 dot of t, we are differentiating x2 with respect to time t. So what is x1? If I differentiate, what I will be getting? F is a functional operator. F1 of, it depends on the state variables and these are the inputs. The state variables, comma inputs. So if I differentiate x1 dot of t with respect to time t, it is the function of the state variables and the inputs. State variables x1 to xn, state variable states are there, inputs u1 to um, right? Similarly x2 of t, it also depends on, right, state variables and the inputs. So f2 of, right, this is a second functional operator corresponding to this x2 state. Similarly xn, right? So here you can observe f1, f2 and fn. This is the functional operator. You will not understand anything, but this is functional operator. It is the function that is operated on the state variables and inputs, right? So f is another vector, f1, f2 and so on, fn, we call it as functional operator. So in these equations we call it as state differential equations. State differential equations. or simply we call it as state equations, or simply we call it as state equations, right? X1 dot of t, x2 dot of t. Okay, just you try to understand, later on I will tell you everything, right? Next, this is differentiation. If I want state variable x1 of t, this is the differentiation of the state variable x1 dot of t. If I want state variable back, what I have to do? I have to integrate, right? So xi of t, it can be x1, x2, I runs from 1, 2 and so on till n. So xi of t is equal to the initial state xi of t naught plus integration of this functional operator, which is function of state variable as well as input into d of t. X initial state, this is the initial condition or initial state at time t equal to t naught. And what is the state of other states for time t greater than t naught? So it is integrate from t naught to t naught, right? It should be greater than or equal to t naught. So this is the initial condition. We have this state plus integrate this functional operator, which is function of the state variables as well as the inputs, right, from t naught to t, right? So I'll be getting this state variable. This is the state variable I am getting after integrating, right? State variable. Okay, if there are n state variables, this is the equation how we write, right? I runs from 1 to n. I hope, right? Okay, for time variant system, okay, we have written x dot of x, right? X1 dot of t, or simply we'll write for x dot of t is function of the state variables. Let me call it as x, means x1, x2, xn, we call it as simply x, and u1, u2, um, we call it as simply u. For time invariant systems, it is not a function of time. This t will not come. You can see here whether t is coming. No, means these are the equations for time invariant systems. If it is time variant system, if it is function of time, then I have to show t. So x dot of t is equal to function of x comma u. X is the state variables, u is the inputs, and t means it is time variant system. It is indication, right? This is for time variant system. If it is for time invariant, no need to show this t. So we call this as state equation or state differential equation, because it's differentiation, right? X dot of t, state equation or state differential equation, state differential equation. Then I can write this in the same way. 1 minute. I have written the state differential equation for this. In the same way, I can write the output equation. Then the output equation also depends on, it is also a function of the state variables and the inputs. It is so this output is a function of the state variables and the inputs. So we will write it like this. So here it is a function. You have defined f for state equation. Here we'll take that function as g here. G of, it is a function of the state variables and the input with respect to time for the time variant system. We call this as output equation. So x dot of t is a function of state variable and input, and the output y of t is also a function of the state variables and the input. This we call it as output equation. Please try to understand. This equation is sufficient for us. The next, we came to know what is state equation or state differential equation and output equation, and how they are dependent. They are dependent on state variables and input. Next, you can see the representation right here. This diagram we are familiar. This is the multiple input, multiple outputs, m inputs, n state variables, and p number of outputs. Right? For this diagram, we are clear. Next, you can observe here the equations, whatever we have written, state equation and output equation. Right? You can observe here. So, initial state x of t naught. This is the input and this is the output. In between is the state, right? So input of the system, output of the system, and state, internal state of the system. So this is input of the system, output of the system, and this is internal state of the system. How it is represented, we'll see. This you can observe here, right? Okay, let us take the output equation. Y is function of the input as well as a state variable as well as input. You can observe here. So this is the input plus the state variable x of t. So that will give me the output, right? The inputs u of t plus the x of t. This is the summing point. Then it will give me the output. Then similarly the same thing, x dot of t. It is also function of the state variables and the input. You can, here x dot of t is not shown here. right? So the input output state description of a system, that is initial state of the system at time t equal to t naught, this is the initial state, right? Plus for time t greater than or equal to t naught, so other states are there, x1, x2, x3, so that will give me xt, right? So other states of the system will, right, that is added and will get the output y. I hope something you have understood, because when I solve the problem at the end you will come to know all these things, because this is the way how it is, because telling theoretical is different and taking the problem and doing it is different, right? Okay, I will take one numerical and I will explain you there. You will understand all these things whatever I have told, right? Don't worry. Okay, next. So this is the state equations. We will write x1 dot. It is function of state variables. You can observe here x1, x2 and so on xn, and it is function of the inputs, right? u1, u2 and um. Since this is the first state, so we will write a1, a11. With respect to the state variables, we will use the letter a. With respect to the input variables we will use the letter b, right? With respect to state variables we will use a. With respect to the inputs we will use b. So since this is first state, a1, 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 so this is first, right? x1 first coefficient, second coefficient and nth coefficient, right? So a11, a12, a1n, right? I hope you are understanding how the notations they are taking. Similarly for the inputs, b11, b12, b1m, right? A for the state variables, b for the inputs. Okay, similarly for x2 we will write, you can observe here, this 2 means this is for second state, right? a2 of 1 first coefficient, a22 second coefficient with respect to the second state and so on. Similarly xn, x1 dot, x2 dot and xn dot. So all these equations, instead of writing all these things, the general equation will write x dot of t is equal to this, the state variables we take the letter a, right? This is the vector, so it is a vector of all this a11, a12, a1n, a21, a22, a2n, an1, this forms a vector, right? So let me call that as vector a. So we will use letter a for the state variables, we use letter b for the inputs u of t, right? So I can write this state equation as, this is the state equation or state differential equation also I can say. So it is a function of the state variables x of t and the inputs, right, u of t, and these are the coefficients a and b. How we can write it, I hope you are getting. So a is another vector associated with the state variables, b is another vector associated with the inputs. So this is another vector. So this is the state equation or state differential equation. The same thing has been written here. What is this x of t? It is the state vector of order n cross 1. And what is this u of t? It is the input vector of order m cross 1. Already we know what is x of t, state vector, input vector, we know this. Then we should be knowing the new things, a and b. A we call it as system matrix or evolution matrix. It is of the order n cross n. I will tell you how to remember all these things later. Then B is, we call it as input matrix or control matrix of order n cross m. How we will get this, I will tell you after studying a complete state model, right? Okay, this is state equation. Similarly, the output equation, we will write for output equation. Next, state equations are over. State equations means this thing we have concentrated. Next, we will write the output equation. State equation, it is, right? State equation, it is a function of the state variables as well as the inputs. The output equation is also, it is also a function of the state variables as well as inputs. We'll see this. Next, we'll see the output equation. Yes, let me concentrate on y1 of t, y2 of t and so on. The equations can be written as y1 of t, right? It depends on the state variables and the inputs. So I cannot use the letters a, b same, because it is for state equations we have used. A, b are already over. Next we'll use the letter c, c11, c1n for the states and d for inputs, right? So generally we will write y1, y2 and so on yp. Just like this state equation, we will represent the output equation here. Next, so this is the output equation. Y of t is equal to c into x of t plus d into u of t. X of t, I hope you remember that the output equation is a function of the state variables and the inputs. And c and d are, right, c is associated with the state variables for the output equation and D is associated with the inputs for the output equation, just to differentiate. So y of t is the output matrix of the order p cross 1. We have seen already output matrix, right? P cross 1. Then C and D. C we call it as output matrix or observation matrix of the order P cross 1. How to remember I will tell you later. And D is direct transmission matrix of the order P cross 1. How to remember this order I will tell you. Right? Okay. All these things we have studied. If you don't remember anything also it is okay. But finally this thing you have to understand. What is state model of a system? State differential equations you came to know. And what is state model of linear system you should understand. So these two equations, that is this first one is state equation and second one is output equation, right? These two equations we call it as state model of a system. State model of a system. State model of a system consists of writing of state equations and output equations. If I represent my system in the form of state equations and output equations, it is nothing but state model of a system, right? The state equation, general state equation is x dot of t is equal to a into x of t plus b into u of t, and the output equation, general equation, y of t is equal to c into x of t plus d into u of t. You can observe in both the cases, whether it is state equation or output equation, they are function of the state variable x of t and the input u of t. If a b comes means they are the vectors associated with the state equation. C and D, they are the vectors associated with the output equation. C and D. Just to differentiate, we are using different notations A, B, C, D. Right? State model of a system. Then this is for time invariant. If it is time variant, just I will write the function because A is function of time. A of t, B of t, C of t, D of t. So I will show A of t. The same equations. This is for LTI system. It is just we are showing that they are functions of time, right? Okay, we will try to write the state model of single input. We will try to get the state model of single input, single output system. Okay, state model means it should consist of state equation as well as the output equation. Let me write the state equation first. State equation and the output equation. State equations and output equations are equations. Okay, fine, no problem. So this general thing you know. A into x of t plus b into u of t, y of t, c into x of t plus d into u of t. This capital D. Okay. Single input and single output. So m is 1 because single input, p is 1 because single output, right? M is 1 and p is 1. Single input, single output. What is the order? It depends on the number of state variables. So if n is the order, means n number of state variables are there. In such a case, this is the state equation how I have written. Then what about the matrix? So let me write the order of the matrix for vector A, vector B, vector C, vector D. I will tell you how to write. These two are associated with the state equations. These two are associated with the output equations, right? For state, observe here, n, n, n cross. This is output equation means P refers to output, right? P cross. So number of state variables, n stands for the number of state variables, a and b are the vectors. For c and d, related with output equations, p is the number of outputs, right? P cross. So nm, n for number of state variables, m for the number of inputs, right? So because it depends on the state variable and input. State variable is n and input variable is m, nm. I hope you are getting. Is it fine? How to write? For state equations, first you write down nn. For output equation, you write pp. Then you write nm. If blindly you can write. This is the way. I hope you are getting. Then next, here for this single input, single output system, what is this I am getting? We don't know. It is n cross n, right? A is n cross n matrix and n cross m is 1 for this single input, single output system. So P cross n is 1. Sorry, P cross, what is P? Only 1. 1 cross P is 1. 1 cross n. What is P here? 1. 1 cross, what is m? It is also 1. 1 cross 1. So they have written the same thing. A is n cross n matrix. B is n cross 1 matrix. C is 1 cross n matrix. D is constant because it is 1 cross 1 means only one row, one column, only one of the thing that we call it as constant. It will not form a matrix, right? So it is 1 cross 1, only one element will be there. So it is a constant, we call it as 1 cross 1. I hope you came to know how to remember the orders. The same thing I have written here, n cross. So you write nn first, pp first, then nm, nm. Don't worry about these namings, dynamics. So A is called as evolution matrix. Don't worry about these namings, leave it, right? The next, state diagram representation. Okay, it is a pictorial representation of the state model. What is state model? The state model consists of the state equations as well as the output equation, right? Both the state equation, nothing but state differential equation x dot of t, and output equation y of t. They are functions of both the state variable as well as input, right? Those equations, you know what is state model. So the pictorial representation of the state model, we call it a state diagram, right, for the given system. And we will see the state diagram of linear time invariant continuous system. And this state diagram is the interconnection of these three basic units. We have scalars, adders, and integrators. You can see in the first diagram, this is a scalar a or some scalar quantity. So this is the amplification. If I want output here x1, it has to be multiplied by the gain of the system. Means it represents, usually in the electrical circuits, this is an amplifier which will amplify the given input signal. So a into x2 of t. This is the role of the scalar. Then adder, it will add the two signals x2 of t and x3 of t. Here states, I will call it as states, are two signals, right? So x1 of t is x2 of t plus x3 of t. If it is addition, if it is subtraction, you can subtract it. So this is adder. Scalar is over, adder is over. Next, integrator. Yes, I will take the integrator, I will represent it like this. So if I integrate the differential states, that is state differential equation x1 dot of t, if I integrate, I will get the state variables. Means the output of the integrator is nothing but always a state variable. I have written here, the output of each integrator is always a state variable, right? And the input is the differential state equation. State differential equation is the input for the integrator. And the transfer function of any integrator is always 1 by s. Yes, it is fine, right? You know it. So integration of f of t into dt. If I apply Laplace transform for this Laplace transform, then I will get f of s divided by s. So 1 by s, right? So the transfer function of any integrator is always 1 by s. You can see here, right? So 1 by s into f of s. Is it fine? So this is the integrator. So the input for the integrator is always the state equation or state differential equation, and the output of the integrator is a state variable. Please keep in the mind, right? It's a state variable. Okay, we'll try to represent the state diagram of the standard state model. Okay, first we should be knowing the state model. What is state model? So this is the standard state model. It consists of the state equation as well as the output equation. You know how to write these equations. Okay, we'll try to draw the state diagram for this. So we'll take this equation. You can observe here, always the input will be on the left hand side, output will be on the right hand side, and in between will be the state, right? Input, output, and internal state of the system, this entire thing. So we'll try to represent it. Observe here, first we have to get this equation, right? A into x of t plus b into u of t, then only it will give me the state equation x dot of t. How? We'll see. And we know we are using these three basic units, but we will not be using scalars. We will be using adders and integrators here, right? So you can observe here, there is a adder, there is an integrator, there is a adder, right? There is no scalar anywhere. So you'll see here. So I want b into u of t. So this u of t is here. Just add the b block here. So what is the output? B into u of t I am getting. This is fine. Plus, so I need adder. B into u of t plus, this is adder. What I want? A into x of t. So I want x of t, right? So this is the integrator. So what is the input for integrator? The state equation x dot of t. The output of the integrator is a state variable x of t. So this x of t should be multiplied with a block. So it is multiplied with a block, and it is added with b into u of t. So I am getting x dot of t. This is the state equation. X dot of t is equal to a into x of t plus b into u of t. I am getting this. Is it fine? I hope you understood. B into u of t plus a into x of t will give me x dot of t. State equation. I hope you understood. Right? Then next, output equation. How to get this output equation? C into x of t. X of t is here. So just add the block. So I am getting C into X of t at this point here. Then plus D into U of t. U of t is here. Then take the D block, D into U of t I will get. Then take the adder and add it. So C into X of t plus D into U of t will give me Y of t. So this is the state diagram of multiple input, multiple output system. You can observe here, we are not using just lines here. We are using this kind of arrow marks, means there are multiple inputs, U of t, U1, U2, U3, there are n number of inputs. If there are two inputs, only two. So we are using this thick arrow, not the single. This is for single input, this for multiple inputs, and this is for multiple output here, right? So we are using thick arrows in order to determine multiple input and multiple output system. If you don't know how to draw also sufficient, but you should be knowing, that's all. You know all these things, whatever I told. Finally, the intention is to obtain the state model of the given electrical system. That problem I will tell you in detail. I will understand everything. Well, how much is possible, you try to understand later on. After covering this today's lecture, go back once again and start reading from first. You will understand everything very clear, right? I hope you came to know how to draw the state diagram for multiple input, multiple output system. In order to draw the state diagram, we require state model. Yes, this is the state model consisting of state equation and output equation. So we have drawn the state diagram by making use of these two components, that is the adder and integrator. So you can see this is the integrator and adders. Two adders are required, right? Two adders are there. In order to get this X of t, one integrator is required, right? X of t we are getting, right? Yes. If I have the state diagram, I can get the state model, and you go through this. This I will not cover. I just simply, because I will not try to confuse you also. Later on you come and read this, you will understand. The next, state variable representation using physical variables. What are these physical variables? For example, if I take electrical system, the energy storage elements are inductor and capacitor. These are the physical components, and physical variables associated with them is current through the inductor I and voltage across the capacitor. So these we call it as physical variables. And physical components are inductor and capacitor for electrical network. For mechanical network, the damper element and spring element. These are the two physical components. And the physical variables associated with this damper element and spring element are displacement and velocity. This is velocity and this is displacement. Let me represent it as S, displacement. I hope you are getting, right? Okay. And you can see here, the state model of the system is not unique. Whatever the state model, how to obtain state model, I will tell you next by taking one example of the electrical network. I will tell you in detail. So the state model of the system is not unique. If I draw, I will get one state model. If you draw, you will get one state model. But if okay, that will say, I will tell you why it is not unique. Then for second order system, minimum two state variables are necessary. Yes, if I say the order of the system is 2, means there has to be compulsorily minimum two state variables, x1 and x2, right? And to obtain the state model, it is necessary to select the state variables. This is very important. To obtain, I will tell you, obtain the state model of the given electrical network, obtain the state model of the given mechanical system, but we'll concentrate our study only for electrical systems, not for mechanical systems. So obtain the state model of the given electrical system. That is the question, for example. First, what we have to, it is necessary to select the state variables, right? Then how to select the state variables? The various physical quantities of the system are selected as state variables. The physical quantities for electrical systems are inductor and capacitors, and corresponding state variables are current and voltage, right? So we'll see. I'll tell you an example, right? Already the same thing for electrical, the same thing has been told here. For displacement, okay, the same thing. These two things covered already. The next, yes, this is very important, right? So what are all the things we have studied? If I solve this problem, it is as good as I have understood everything, whatever we have studied till now, right? So I will explain you step by step very neatly. Please try to understand, right? So if you understand this numerical very clearly, then you have understood today's lecture completely, right? So please concentrate. Okay, the question is, obtain the state model of the given electrical system. This is the electrical system. Vi of t is the input, V naught of t is the output. The elements are resistor, inductor and capacitor. They are connected in this fashion. The current I of t is flowing in this direction, and this is V naught of t. This is the voltage across the capacitor, right? All these things you understand. This is the given thing. Then let us solve step by step. You try to understand this. If you understand this problem, how to obtain the state model, then you have understood today's lecture completely, right? Please concentrate. Then once again, go back, starting from first slide, read everything, you will understand everything. It is the, that is the, actually it is reverse engineering, but there is no other way, right? Okay, fine. What they are telling, obtain the state model. Okay, what does the state model consist of? It consists of state equation and output equation. Let me write the state equation first. State equation. What is state equation or state differential equation? It is x dot of t is equal to a into x of t plus b into u of t. How to remember this? It is a function of the states or state variables and the inputs u of t. So a and b are the vectors associated with the state equation. Similarly, let me write the output equation. Output equation y of t is equal to, we are using the same thing, x of t, u of t remains the same, but instead of a and b we'll use c and d. C into x of t plus d into u of t. So these together, these two equations together represent the state model, represents state model of the given system. It may be electrical system or mechanical system, right? So okay, fine, I have understood this. Then what are the orders of this? Let me write it here. A, B, C, D. These are the vectors, right? What are the orders of these vectors? So A and B for state equation, C and D for the output equation. Now, so M, N, P, please be clear. M represents the number of inputs. N represents the number of state variables. P represents the number of outputs. I hope this is clear. I have stressed there. I have repeated. M represents the number of inputs. N represents the number of state variables or internal states of the system. And P represents the number of outputs. M, N, P. So C and D are outputs, right? Output, they are related to output equation. So P. So I'll write P. P cross something. P cross something. And A and B, they are representing the state equation, right? So N is the state variable. So N cross. So for state equations, N cross something. For output equation, P cross something, P cross. So I'll write NM. Please write. I hope you are getting NM. I hope you are getting what I have written here. How to write I have told. Now, okay, this is the basics. If I understand, then I can solve this problem very easily. So here, okay, first, what are the state variables? First, this I have told. In order to obtain the state model, it is necessary to select the state variables. So which are the state variables here? So which are the energy storage elements here? Energy storage elements are first inductor and second one is capacitor. So inductor and capacitor, L and C. And state variables corresponding to this is current I, and corresponding to this capacitor is voltage. What is the voltage across this? V naught of t, right? The voltage across this capacitor is V naught of t. So V naught of t is the variable, and I of t I'll write because it's function of time, right? So these are the state variables. So the energy storage elements are physical elements in the network are inductor and capacitor, and state variables are I of t associated with the inductor, current flowing through the inductor, and the voltage across the capacitor. So I of t and V naught of t are the variables. So what is M, what is N, all I should write. So we will write one by one. So what is the input? Okay, first state variables, right? So I of t and V naught of t. So state variables means, let me call it as x1 of t. So let me take this as first state variable I of t, this current I of t. Then which is the second state variable x2 of t? It is nothing but v naught of t. V naught of t. Then what is the input? U of t. U of t is input, right? We know u of t. So which is u of t? Its input is vi of t here. Vi of t. And what is the output? Y of t. It is nothing. Y of t is nothing but v naught of t. Y of t. Y of t is equal to v naught of t. So these two are the state variables, and this is the input, and this is the output, and these are the state variables. Is it clear? Next, and m and p. What is m? What is n? What is m? How many number of inputs are there? Only one input, that is vi of t. M is 1. What is, how many state variables are there? 2. x1 of t and x2 of t, I of t and v naught. So n is 2. How many outputs are there? Only one output, v naught of t, p equal to 1. I hope you came to know what is m, what is n, what is p. Then you can write what is n m p, what is the right n cross n, n cross m, these things you can write, right? I hope you are getting. So we have found out m and p. Next, we will write the Kirchhoff's voltage law by KVL. By KVL, we will write the state equation, right? So vi of t is equal to vi of t is equal to I of t into R plus L into di by dt, L into di of t by dt. Simply I can write di by dt, but they are functions of time, so I of t, that's all, plus. And here the voltage across capacitor, it is v naught of t. So I into R of t plus L into di by dt plus I will write v naught of t. I will not write 1 by c into integration of I of dt, right? I will write v naught of t. I can write, no? V naught of t. I can write it, right? So call this, okay, this is fine. This is by Kirchhoff's voltage law. We have written the loop equation. Then replace these elements. What is vi of t? Vi of t is nothing but your u of t, right? Vi of t is nothing but your u of t. I of t. What is I of t? I of t is nothing but your x1 of t. X1 of t into R. I hope you are getting. L as it is. Yes. What is d? Di by dt. What is I of t? I of t is nothing but x1 of t. So d x1 of t by dt. I hope you are getting. Just I have replaced this I of t by x1 of t. Plus, what is this v naught of t? Don't write y of t because we are writing state equations first. So let me write it here. State equations. State equations. First we are getting state equations. Because state equations, 1 minute. Let me take the ink pen. First we are writing state equations, then we'll go for output equations, right? So first we are writing the state equations, this one. So I am written state equations. So don't take this v naught of t as y of t because we are not writing the output equation, we are writing the state equation. So v naught of t is x2 of t here, right? X2 of t. I hope you are getting, right? So what is this d by dt of x1? X1 dot, right? What I want, x of t dot I want, right? So keep this and send others on that side, right? So I hope I will write it. Please observe x1 dot of t. I will keep, and u of t and other things I will move that side. So first what should come? Observe here. X of t state should come, then input should come, u of t. So states x1, x2 should come, right? So let me write it. So let me write one more step. L into, let me write it, no problem. L into x1 dot of t, right? So first I will write the state equations. So if it is kept here, these things will be moved. Minus r into x1 of t. We are taking this side. So minus x2 of t. First we are writing state equations because first x should come, then input u. Then I will write, this is taken, u of t is here. So plus u of t. I hope you understood. So L into x1 of t is equal to minus r into x1 of t minus x2 of t plus u of t. So but I want only x1 of t. So let me write it as minus r by L. because this L is there, no, divide it. So R by L into x1 of t minus 1 by L into x2 of t. There is the reason why I have not written x2 of t divided by L. 1 by L I have written plus 1 by L into u of t. So this is the state equation, first state equation. See how many state variables are there? Two state variables, x1 of t and x2 of t. I have got the first state equation, x1 dot of t. Similarly, I should get x2 dot of t, right? So first state equation I got it. Call this as equation number 1. Next, I want x2 dot of t. So it is nothing but v naught dot of t, means dv naught by dt I want, right? What is v naught? So I want x2 dot of t, right? So x2 dot of t is nothing but v naught dot of t, means dv naught by dt. So I should get the differentiation of this voltage v naught by dt. So what is v naught of t? We'll write v naught of t. What is v naught of t? It is the voltage across this capacitor, 1 by c into integration of I of t into dt. You agree with this, right? So v naught of t is 1 by c into integration of I of t into dt. Is it fine, right? So what actually I want? dv naught by dt, because I want x2 dot of t means v naught dot of t. So take the differentiation of v naught with respect to time t. So dv naught of t by dt is equal to, so this integration will cancel because I am differentiating, right? So 1 by c into I of t I am getting. Is it correct? Right? Differentiation. So 1 by c into I of t. So what is this? Okay, let me rewrite this once again in the next slide. dv naught by dt is equal to 1 by c into I of t. What is this d by dt of, what is this v naught of t? V naught of t is nothing but x2 of t. So I am replacing 1 by c. What is this I of t? I of t is nothing but x1 of t, right? I of t is nothing but x1 of t. I am replacing. I hope you are getting. Next, this can be written as, so let me write it here, x2 dot of t is equal to 1 by c into x1 of t. Call this as equation 2. So state equation is over. This we have covered because two variables are there, x1 of t and x2 of t. So I got two state equation, x1 dot of t and x2 dot of t. x1 dot of t, this is equation 1. x2 dot of t, this is equation 2. State equations are over. Next we have to obtain output equation. So I'll write output equation. So based on the number of state variables, those many state equations we are getting. Here there are two state variables, so we are getting two state equations, equation 1 and equation 2. Next, only one output is there, right? So only one output equation we are going to get. So let me write it. So with respect to output means this one, right? So v naught of t is equal to what? 1 by c into integration of, 1 minute, and observe here, y of t is equal to c into x of t plus d into u of t. We'll see, right? So v naught of t is equal to, at the output side, right? This is y of t, right? So v naught of t is equal to 1 by c into integration of I of t into dt. This is fine, right? 1 minute. Okay, no need to do this thing because we already know that v naught of t is nothing but x2 of t, right? 1 minute, yes. Y of t is equal to v naught of t. So y of t is equal to v naught of t, and v naught of t is equal to x2 of t, right? It is already function of the state variable, right? No need to get this equation, directly we'll write, right? Is it fine? So what is y of t? Already we have seen. What is y of t? I have written here. It is v naught of t, the output, right? V naught of t. So what is this v naught of t? It is x2 of t, right? It is nothing but the state x2 of t. Is it fine? Yes, this itself is the output equation. And you can observe here in the output equation, if we have x of t, but we don't have u of t, means that is 0, d is 0, right? We will write. I hope you can see this. Call this as equation 3. Okay, fine. And okay, we'll write these state model equations finally in the form of vector, right? So this is the output equation, and 1 and 2 are the state equations. So we will write the state model of the system, right? Clubbing equation 1 and 2. So I should get this. So let me write this for reference. X dot of t is equal to a into x of t. This will help us to write. So I am writing this b into u of t. So this is the state equations. What I am going to, what is x dot of t? So look at equation 1 and equation 2. Equation 1 is here. Observe x dot of t means x1 of t. This is a vector, right? So let me write it x1 dot of t into x2 dot of t. This is one vector, right? Is it fine? I hope it's correct, right? x2 dot should come because x dot, right? So x2 dot and x1 dot are covered from equation 1 and 2. It is equal to, what is vector a? We'll see. And what is the order of vector a? A, b. We'll see here. So state equations means n. N is 2. Number of state, yes sir, right? So n cross, what I will be getting? Just I'll write it here. N cross nm. So n cross n means 2 cross 2. The vector what I should get is 2 cross 2. B is n cross m. 2 cross, what is m? How many number of inputs are there? 1, right? So it is 2 cross 2 vector what I am going to get here, right? Then x of t. What is x of t? There are two states. x1 of t into x2 of t. This one x of t, right? x1 of t, x2 of t, and this should be order of 2 cross 1, this vector a. So what are the elements that should come here? Just observe here. Go to equation 1 with respect to x of t. Observe the coefficients x1 of t, x2 of t, right? So you can observe here for x1 of t. First we'll write for x1 of t minus r by l, minus r by l, minus r by l. So second element with respect to x1 of t. Observe the second equation. So here second equation is 1 by c, 1 by c. So I will write 1 by c. Don't write here because this refers to x1. Next we will write x2. So observe, go to equation 1. What is x2 here? Minus 1 by l with respect to x2, minus 1 by l. Then observe equation 2. So there is no x2 of t, so it is 0. So we came to know how to write down this matrix A, right? This is matrix A and its order is 2 cross 2, 2, right? 2 rows, 2 columns. And this is x1 of t. Two states are there. X of t corresponds to this vector, state vector x1 of t, plus what is B? It is 2 rows and 1 column. So I have to fill up this. Then what is u of t? How many inputs are there? Only one input. So I'll write u of t, right? Is it fine? Only one input is there. Is it fine? U of t. Yes, we'll write it. So what should be B? Just observe equation 1. Observe equation 1 along with u of t. So you can observe equation 1 by L is there. So write down 1 by L. This is the first element. What about the second element? So observe second equation. So it is u of t is not there. Means it is not there means 0 into u of t. 0 I will write. I hope this is the state equation, right? I hope you are getting in the vector form. This represents vector A, this represents vector A, this represents vector B. And order is 2 cross 1 and order is 2 cross 2. I hope you are getting. Then similarly we have to write the in the vector form for output equation. This is for state equation we have written. This is for state equation. State equation. Then for output equation we'll write. So let me write that output equation, general equation. Y of t is equal to c into x of t plus d into u of t. This is the general equation. What are the orders of c and d? Let me write it here. So it is output means p cross, output p reference p cross nm. So how many outputs are there? Only one, and number of states is 2. Output is 1. How many number of inputs are there? M. It is only 1. I hope you are getting. C 1 cross 2 matrix, D 1 cross 1 matrix. So y of t. So observe the equation 3, right? This one. So y of t, it is only 1. It is equal to, what is c? It is 1 cross 2, only one row, two columns, one row, two columns. So two elements should come, right? Into x of t. Observe x of t here, third equation 3. With respect to x of t means, so x1 of t is not there, only x2 of t is there. So x1 of t is not there means write 0. x2 of t, what is the coefficient? It is 1. So I hope you are getting, along with x2 of t, right? So here it is x of t means state equation x1 of t into x2 of t. I hope, right? Observe coefficient x2 of t is there, right? So this coefficient represents the coefficient of x1 of t. It is not there, it represents 0, and coefficient of x2 of t is 1. You just multiply first row and first column, 0 into x1 of t, 1 into x2 of t. So I am getting 1 into x2 of t. I am getting back this. Plus d is not there, it is constant, 1 cross 1. So it is not there, it is 0. Because u of t is not there, right? Input, it is not depending on the input here. So it is u of t. 0 into u of t I written, because it's 1 cross 1 matrix, right? So this represents C matrix and this represents D matrix, and it is constant here. It is 1 cross 1. So this is the output equation vector. And this complete these two vectors, we call it as state model of the given system. State model of the given electrical system. Yes, I hope you understood state model of the given electrical system. If any doubts, you can unmute yourself and talk to me so that I can clarify your doubts. I hope you understood how to obtain the state model of the given electrical system. Is there any queries? Any queries? Shall I go move to the next problem, next numerical? Shall I take up? Right, still half an hour time is there. Okay, you are not asking anything means I assume you understood. Okay, the next, the same thing, the solution is given here, right? And the state model is not unique. Why it is not unique, I will tell you. Because see here, while choosing x1 of t, I have taken I of t. While choosing x2 of t, I have taken v naught of t. For x1 of t, I can take v naught of t. For x2 of t, I can take I of t. So the state model will be different if I choose in that way. So always you go like this. First I of t comes, take this as x1, right? With respect to inductor. With respect to capacitor voltage, you take x2. You can change it also, right? If you interchange, the state model will be different, right? Okay. So state model of the system is not unique for that purpose. So the same solution has been given. Next numerical, the advantages, you go through it. Next